Hello, yeah, I'm going to present a lightning talk for our paper, LLMs at bargaining table. As large language model becomes more and more important and popular, in this paper, we would like to envision a future in which important decisions are made by AI agents powered by large language models instead of humans. In particular, we would like to ask how can we rethink economic scenarios such as auctions, negotiations, and shoppings in the era of AI agents. Auctions for LLM has been mentioned several times in this workshop, and it's not hard to imagine that in the near future, maybe we can have shopping assistants that can help us to make important shopping decisions for online shopping, for example. And in this paper, we focus on negotiation. And we would like to examine whether the current technology of large language model can empower AI agents to perform strategic negotiations with minimal prompting. We consider the simplest setting of bilateral trade. So a trade between one seller and one buyer. In this setting, we let two LLM agents to interact with each other. One LLM agent would act as the seller's agent, and the other LLM agent would act as the buyer's agent. And for the seller's agent, we will provide with a seller's prompt, including the seller's private cost. And similarly, for the buyer's agent, we will provide with the buyer's prompt with the private buyer's value. In this negotiation game, we assume the seller will take the first action. And to prompt the seller's agent to conduct strategic reasoning, we specifically ask the LLM agent to come up with a strategy first before they perform the action. So in each round, both the seller and the buyer's agent will come up with a strategy first, which is private is a private message. And then based on their strategy, they will send a public information to the other agent. We will keep the negotiation going until a trade is achieved or the negotiation collapses. In addition to ask the LLM agents to explain their strategy first, in order to constrain their strategy space, we ask the LLM to choose actions in the following options: either offer a price, accept a price, reject a price, make a counter offer, or end the conversation. And here we would like to showcase a conversation, which is generated by Gemini powered by Google. Initially, in this example, sellers has a. In this example, the seller's private. In this example, the seller's value is sales cost is $1,000, while the buyer's value is $1,100. And this example, we can see that all the actions kind of follow their strategy. In addition, we perform experiments by varying the seller's cost and the buyer's values. And this heat map for the left bottom corner, in which the buyer's value is higher than the seller's cost, we seldomly observe trades, while for the top right corner, in which the seller's cost is smaller than the buyer's value, we trade with really high probability, and we achieve more than 90% gains of trade. We further compare the theoretical predictions in settings with different information structure and experiment with prompts to change the level of patience of agents. Thank you for your attention. We acknowledge that all these results are quite preliminary and there are a lot of limitations and caveats. If you are interested, please stop by in the poster section